Hi, I'm Gregg Oldham, Senior Product Manager here at Ideagen, working specifically within the quality business line and looking after unique products associated with quality control, quality assurance. I'm joined by my colleague Steve Allison, and together we've got 35 years experience, which we want to share with you in a conversation around quality processes, manufacturing processes.
Gregg, just from your experience from working in the manufacturing environment, what do you see as kind of good practice, from taking a part from an OEM, winning that business, to then obviously the production planning side of it, through to that finished component. It can be from various different, different markets. Oil and gas, aerospace, defence, nuclear. What do you see?
Well, I think, all them different industries, they should all follow good working quality principles, practices. I mean, you mentioned there at the beginning, from contract. I mean, one of the biggest things when you get that contract, as in, are you going to tender for it? Are you going to be able to produce that part and deliver it to your customer, is a contract review. So when you look at the stages, you've got the contract review then that is going to go through all the different heads in that organisation, whether it's the engineering manager, the methods of how they can manufacture it, the quality. Have we got the accreditations in place? Have we got the correct equipment? Is there anything that's going to catch our eyes on? So it's going to touch everybody.
Like tooling and stuff like that as well?
Tooling. So then, there's things there that are going to stand out. No, there's further investment required, or yes, we can do that. We've done that before. We've got examples and similar parts that we've done in the past. But then, obviously that's one stage, and there might be lots of these coming in that go and you win. Then it's all about manufacturing it, the planning. But I guess there's an important thing here. In some industries, there are standards that drive certain things that give good indicators, good practices. So, my experience has all been in the aerospace manufacturing, aerospace engineering. In there, we've got AS standards, AS9100. You've got the AS9100 for first article inspection reports. They're often, you'll see those in that actual contract that comes through in the purchase order as a requirement. Now, for those outside of the aerospace manufacturing industry, it may be that they don't recognise that, but what you do recognise, or what they will recognise, is the process in which it follows, because for all intents and purposes, a design specification, an engineering drawing, that is what you've got to manufacture with the dimensions. Anybody in manufacturing of any of them industries that you've just mentioned are going to be looking at that and deciding, okay, I've got all this, these are the operations that it's going to go and touch, and how I'm going to manufacture it, and at the end of it I need to verify that I have manufactured it correctly. So in its simple terms, capture all them requirements, have an inspection plan, and record them results. Now, obviously, we talk about software to help with those situations, AS9100, FAIR, but it's about not being distracted by the other industries that AS9100 is. Oh, I don't do that. But you do follow those principles. So there's benefits there. But that's just one indicator. That's just one thing where you're proving that the part you are manufacturing you're capable for that one batch, that one indicator, that one part. You're proving that you get the materials from the right place, you've carried out the processes and so on. But as time goes on, when you look at APQP and the automotive industry,
that's what I was going to say. Taking a step, when that's at kind of the end of the process from manufacturing the part. When you actually manufacture it and you're verifying that part is to print. But taking that step back, you've got, how do you get to that point? And obviously there's methods in which you can use to get to that, to reduce the risk.
Yeah, and that's where that APQP, the Advanced Product Quality Planning, or PPAP from the automotive. I mean, again, in aerospace, it's the AS9145. But that is looking at advanced practices before you're even touching the manufacturing of the batch. What can you do? What are you looking at in your organisation to prevent errors, to alleviate risk? Ultimately, to ensure you're getting the right quality from your processors, you're delivering it, and you're achieving the cost that you spec'd out in the contract review.
And that's typically what a lot of what I'm aware of from my time in subcontract manufacturing, you know, providing parts to multiple different OEMs, is you are KPI'd on quality, on-time delivery, and then obviously cost comes.
Yeah.
But the quality and on-time delivery, you can't deviate on that. That's always, you know, they're always striving for 100% on those areas, and it's how you get to those areas, and typically they're joined as well. So the quality typically has an effect on on-time delivery.
Yes.
And that's the way it flows. But so talking a bit more around, you know, like the contract review stage, from an example I've got from industry, you know, just like you mentioned, when they pull people in for a contract review, they've got maybe, you know, the department heads, you know, all in, and they're looking at that project or the purchase order, and evaluating the risks with that. But that tends to be, you know, in a silo.
Yeah, and
if
you're doing it in that moment in time, that silo, are you actually doing that effectively? I mean, I don't know in terms of your example. I mean, you've probably got your thoughts on that, but better ways of doing that, more time, more review, actually looking at the risks rather than it being a very quick tick box exercise. I mean, there's costs associated with having people in one room as well, rather than giving them the time or the flexibility to do a contract review. I mean, did you experience any of that or see any of that?
What we experienced was it was more reactive. It was more reactive in terms of the agreement from that process, the way that was structured. That was seen to be the right way, and you're pulling on your knowledge. The people in the room are pulling on their knowledge, but then there's always other factors that's maybe not getting taken into account, because it's all getting done at that one time. So when they then get into the process of the actual manufacturing side of it, they're being more reactive to the risks that are coming up, whereas
not proactive.
You know, have you experienced, you know, the proactive side of it, you know, like by spreading that process out?
Yes, and the proactive way of thinking is probably a little bit in my personality, the way that I would approach things. I mean, in terms of contract review experience for me, way back in engineering when I was there, it was a case of not having everybody in one room together to review that contract and do it very quickly, but give time that the documentation would go to each department for review, and they would have time, so it would be done correctly. Now, I'm not saying, I've probably used the word correctly. I mean, whether it's correct or not, that's another thing, but it worked. It gave time, and what that allowed, so at the time I was, here's one example of how I used it proactively, what it came to. The quality manager at the time had a review, contract review, and it was for some rings that go in an aero engine, only about 8.5 inch diameter, but he gave it to me because I was responsible for inspection at the time, and the department. He said, just something for you to look at. Have we got the capabilities for this? The engineering manager is going to look at the capabilities for manufacturing, but there's one key feature on this drawing that is a tight tolerance. Now, this tolerance was a 8.5 inch diameter, external diameter, with a total tolerance of 7/10. Now, that is a lot. We had that band to work in. So straight away it was like, well, we've not got the gauges, to go one decimal place beyond that if you want accuracy, certainty on the measurement. I wouldn't be overly confident with a micrometer. So then in my head I was thinking about like the root cause analysis, the Ishikawa, the fishbone diagram. I was thinking about the people that were inspecting it, the methods of how they might be inspecting it. Obviously, are you going to put this ring on the table and use the micrometer with your right hand, your left hand, or you're holding it? You know, all the things that was going through my head that was where variation could be created.
So that's we're talking about one dimension.
This is one dimension.
One dimension on a part.
But this flagged it up as a key feature. So then I came back to the quality man and I said, right, there's some investment required here. What I think we need is a fixture to hold 2 digital probes that I know I can get the next decimal place recording. We need investment in making a sample part, but sending that sample part away to a calibration outfit to get it certified for a known size, so that every time we have this for inspection, we can slide it through, we can zero it, and we can see the degree, whether it was plus or minus, from the known size. But before we do any of that, because of that tight tolerance, thinking about the environment, temperature control, let it settle for 24 hours minimum, and then inspect and document the sizes. Now, I then came back and I kind of like rolled over a little bit to the manufacturing side. I said, well, the engineering manager, they're going to look at the techniques on grinding, manual grinding, the skill of an operator. As much as you've got that limit, from an external diameter, they're going to work to top limit to always give themselves the opportunity to take material off. Because as soon as you go on bottom limit, that's it. No more material you can take, or you took too much off.
You can't add it back on.
No. So that kind of like worked well, and we fed that back into the costing and the contract and so forth, and we manufactured all these rings and we delivered them to the customer, only to find, and this was what really kept me up at night, when we got rejects. 8 months later, we got 20 odd rings back that we'd manufactured, all serialized, saying that these are undersized. And I was like, I was gobsmacked that they were undersized. I worked the same process again, 24 hours, let it temperature settle. I got the exact sizes that was on my original recordings. Now, you go back to the data collection. This is when I started talking about good working principles of you've got to manufacture and capture the data. Because we'd done that and we got the data collected, we could easily go back and look at the results that I'd created 8 months ago, verified those results with serialization and serial numbers, and everything was fine. Now,
and you've also looked at, you've got your FMEA there, where you've looked at, you know, the risks involved in
partly of it, I mean, I guess the FMEA side, it was partly in my head. I mean, I've got an example of doing an FMEA, but I'm always thinking along those lines. Just to touch on that root cause bit, we reached out to the customer. We said we need a meeting. We went down and presented all the results, took my jigs and fixtures, and bearing in mind this environment thing, I know what you're going to think in a minute when I say I asked, could you show me where you're storing these parts and how you're inspecting them to say that they're undersized so that they don't reach the assembly line? It took us down to a warehouse. Bearing in mind it was February, I still had to have my coat on. It was cold in the warehouse, off the shelf in the same packaging that we'd packed up 8 months ago. And they got it off and inspected it. And straight away, I said, have you not considered the fact of this temperature in this environment on such a fine tolerance that is identified as a key feature by you as a customer, that it could affect the variation in part?
But as part of your planning, or when you preempted that, that's why you baked in the 24-hour of settling and resting for that material to rest. Whereas the client at the time hadn't. No. They hadn't taken that into account. And we all know that the materials do expand or contract depending on the temperature. So but so in effect, you know, you had been looking or planning for that potential, you know,
just
to
proactive,
happen. Yeah, being proactive.
Yeah, yeah. So like I mean, the use of, root cause analysis, non-conformance, something goes wrong on the shop floor. We all know that it's a reactive tool to something. Now you've got an error.
Yeah.
And the investigation then as to, well, what went wrong, what caused it.
Yeah.
But more importantly then, what can you put in place to correct it now, or put in place to prevent it from happening again in the future. I mean, just on that basis there, I mean, I know you've got an understanding of quality management systems and stuff like that. I mean, that to me, just on root cause non-conformance, what would you say is a good thing to have in place to help with capturing or recording the information? How does that feed back into manufacturing of the next batch to stop things happening?
So typically from my experience, it is a manual process, because it comes from, you know, the operators on the shop floor in the manufacturing environment, and they've got to feed that information. Tends to be back through into the quality department, who manage, you know, the non-conforming process part of it. But that obviously pulls in the departments as and when required, depending on the stages that the non-conformance process goes. Now, places use 8D, the 8D process. It could be a lot simpler than that. It doesn't need to be, you know, a full-blown 8D. It could be a 2-3 step process to working out, you know, do we then go to the customer, ask for a deviation request, or do we is it fit for function, or is it scrap, because it is a, you know, in your case, that aerospace component for an engine specifically, with a tolerance like that, likelihood they're not going to accept, you know, that deviation. But the tools in which they use tends to be round about your kind of office tools, you know, Word, PDF, and that side of things. So yeah, no, but it's interesting from your example, from, you know, that component, and then my example from a contract review stage. You know, the two are very different. One's more reactive, one's more proactive. And the OEMs and clients are pushing towards that proactive side. They want you to be proactive, and that's where, when we're looking at standards, new standards coming in. You know, we've got AS9100 coming into the aerospace. We've got AS9100.
New one
for the engine manufacturers. And then obviously the verification AS9100, which has been there for a long time.
Started really with that.
And you know, you mentioned at the beginning, these standards are being baked into contracts. They were always spoke of and known of before. You know, and it was something that we're doing that as a vendor. We're doing that, and we've got examples of doing it. But now it's been becoming more a contractual piece of, you know, requirement, and you need to provide that evidence to your client, and it can be, you know, on the spot. You know, show me your documentation for that. And I think that's an area where a lot of vendors are finding it difficult, because they are doing it. They are doing it, but I think a lot of them are still doing it, you know, with the knowledge in their head. They're not documenting it. It's a documentation part of it.
So when you come back to that then, we're touching now on systems, processes, procedures that can help look after that and maintain it. So, I mean, right from contract review, retention of documents in an organised, structured manner, software can help with that. Procedures around your quality management system, ISO 9000, you know, if there was an impact for non-conformance and an adjustment to a process to prevent it happening in the future. Things can get updated, and I think it's more, in this case, it's about the efficiency and time to make those adjustments and changes, and everybody being part of it and seeing and knowing that is, well, we're coming back to the basics again. We're coming back to improving quality, improving delivery, because that error that happened 6 months ago had a knock-on effect to, well, first of all, quality was not, I won't say poor, but there was a defect. Delivery would have had an impact on delivery, but by continuously improving, and that's the word, continuous improvement. It's like, what does that mean? It means many things. It means everything that we're talking about here, from the beginning, the stages, the capturing those procedures, processes, documenting it. It's all continuous improvement. And whilst you can look at continuous improvement in isolation for just one aspect, maybe just manufacturing of something, there is everything. And it don't just stop there in our just business unit. We're one business unit as a supplier to an OEM. There are other business units as suppliers. The continuous improvement has to happen at all of these, but you know, we know the support is there from the OEMs, and we know that over time how that has resulted in education, because some of these suppliers may see these things in contracts that might just be a tick box exercise, that yes, we've done it, but are you doing it and using it as proactive tools, PPAP, FMEA, mapping the process, looking at the risks in them processes? So that's, I mean, if there's one little tip I've got from that aspect, when you look at the FMEA and mapping out the process, one, the FMEA has to be done as a team. It's never done as an individual. I know I've been into organisations when we're supporting implementation of software where it's one individual wanting to create an FMEA on an Excel spreadsheet. And so straight away, team. Get your team together, get buy-in. They are the experts at various stages of that manufacturing bit. It's not you as one individual. When you map the process, you can do it on paper, but go out and look at that process, but don't start from the beginning and walk it to the end. If you was to start at the end and then work yourself backwards, you see it from a completely different perspective. You'll see then the FMEA you've put together, there will be other risks that are highlighted visually compared to what you believe or perceive is down on paper.
And that's a good point, because when you're actually in the environment as well, there's things you know actually in the manufacturing shop floor. There's all very well doing this in the office, but you know, actually engaging in that environment and seeing that process and seeing where things are going, also, you know, gives you other risks, brings in more risks, but those are contributing factors to the product quality at the end of it.
I've got a good example actually of this. It wasn't me personally, but I was working with a customer as an example where foreign object debris, FOD, was not highlighted in the FMEA as a risk. So they'd done it all, and it was a low risk priority number. They demonstrated that they were doing everything right. They had trays which was identified visually with black tape or black paint on it, that's the dirty tray. That is a tray that carries these components around the shop floor during manufacture. When it's been manufactured and it goes to the cleaning stage, the black trays do not enter the cleaning environment. The black trays stay there. They are then trays identified with white tape or white spray that are the clean parts. So visually, you know, dirty parts, clean parts from the cleaning into inspection, and parts are being inspected. But on an audit, looking for FOD, they found that there was evidence of FOD in the white trays. And it was like, how can this be? Because we've done everything we can from the FMEA perspective, risk is low. We're looking at standardisation, as in the colour coordination of these trays. So the walking of the process was where it got identified.
Yeah.
But it depended when in the year you was looking at this process, because whilst you could look at, and this is where the example is, you've got inspection which was open in the shop floor, you had a 6-foot barrier screen, and then you had the deburring section. Deburring by its own nature is dirty, but you can keep it clean by having extraction fans, working in your own booths, and this, that and the other.
Yeah.
So they considered they'd done everything right. It just so happened at this time, when you walked the process in the middle of summer, there was a roller shutter door outside of deburring that they opened to let air in to cool them down, because it was hot on the shop floor in the middle of summer.
Yeah, 25, 30 degree
Yep.
heat. Yeah.
The wind was blowing.
Yeah.
That was enough to travel dust, FOD, into these white trays that got picked up. Now, that would never have been thought about, covered, doing it in isolation as an FMEA, looking at the risk, which is why they had it as a low risk priority.
Yeah.
But it was only picked up then and a failure. But again, I mean, that's not something out of tolerance, but there's still, that is a non-conformance.
That's an effect. Yeah.
Yeah, the effect, there's a non-conformance raised there. There's now another corrective action and preventive action that has to take place.
Yeah.
And only documenting all of that you've found then can go back in. And that really, I guess, shows the true extent of if people are using a process failure modes and effects analysis correctly, it is a ongoing tool. It is not a one-hit wonder, there and then, there's my FMEA.
Yeah.
Because you're going to get things highlighted. You're going to address them. You're going to continually improve. And if you look at the Pareto of things, they then come down in the risk priority number, and those that were at 4, 5 and 6, 6 months later, all of a sudden 1, 2 and 3,
Yeah. Yeah.
you'll address it. I mean, that's,
Yeah.
so tips there, team, process flow, walk it backwards. Steve, with your experience, many years experience in the manufacturing industry, have you got examples of the use of creating inspection plans and the methods used in that approach? Was it good? Was it bad experience? Is there anything you can relate to?
Yeah, got some. I do have a good example in terms of from that, subcontract manufacturer providing the component to a service provider and then to the service provider to the operator.
Yeah.
In the oil and gas industry. The subcontract manufacturer producing the inspection report manually, so handwritten inspection reports.
Yeah.
Now, some of the subcontract manufacturers, they do produce them for machinists and inspection side of it. But as I said, they can still be handwritten.
Yeah. Yeah.
But the example being that the parts were provided and they went all the way to the operator, and the operator put them downhole.
The operator being the customer.
Being the customer, yeah.
Okay. Yeah.
Put them down, the parts downhole, and the first one never worked.
When you say downhole, is this a drill in the oil? The drilling for oil?
Yeah, when they're drilling for it.
Yeah.
It was in the Middle East.
Yeah.
And they pulled the part out because it wasn't working and put the next one in.
Yeah.
So it was a batch of 3.
Mm-hmm.
All 3 weren't operating, and for whatever reason. Now there was a root cause done on that. It went all the way back to the
original
source,
supplier.
the supplier, yeah. And it was found to be a 2mm bleed hole or pressure release hole that was missing from the parts.
Oh crikey, yeah.
Now, what was, if that had been captured on the inspection report, then chances are that 2mm bleed hole would have been put on the part.
Yeah.
but because it wasn't actually detailed on the inspection report,
It got missed.
it got missed. It resulted in that subcontract manufacturer losing, losing business. They lost
Yeah.
£7 million worth
Yeah.
of annual revenue
Mhm.
from their customer.
Mhm.
So it damaged, obviously it's reputational damage
Yeah.
as well as financial damage
Yeah.
on them. And that reputation probably took them, could be 10 years, 15 years to build up,
But yeah.
and that was lost from a 2mm
Crikey.
blade hole missing from the part.
So if you had your time again, go back 10, 15 years, knowing what we know today with software, if people are resonating with that, listening in, and I've got experience of that, or that's something we do today, we know from our point of view there's software available to take that engineering drawing in the first place.
Yeah.
You will have captured everything with features on there to show missed features or not. There's no mistaking in the handwriting, so your 3s and 8s aren't misguided. They'd go into electronic report, an inspection plan, and it would have made it through to inspection.
Yeah.
Now, that's one thing. Engineering is another thing to produce the 2mm, but it would not have got to the customer. And that, to me, is a sign of we can measure the cost of poor quality, as in the errors and the build-up or reputation or loss of revenue.
Yeah.
But the cost of good quality there, for a small investment...
Small investment versus losing £7 million
Yeah.
worth of business, you can weigh that up and,
Yeah.
what way you go.
Yeah. So today, Steve, we know that OEMs are issuing purchase orders and building into that contract of purchase order to suppliers the adherence to industry standards. I mean, mainly here I'm talking about aerospace with the likes of the AS9100 to produce a FAIR, or AS9145 to produce a PPAP. But if you've got examples or experiences, what do you do in terms of ensuring that the review of that contract is done in a thorough way? Good experience, bad experience? What
So often we hear from the suppliers that they are receiving these requirements from their customers, such as contractually, such as AS9145, AS912, 102, or AS13100, and they're asking why is it being driven contractually now? And the big reason for it is that the OEMs, the customers, are trying to drive the supply chain to be more proactive in their planning for production of their components, of the parts, looking at all the process, because typically the way a lot of vendors or subcontractors are working, they're working in more of a reactive state. So they receive that order, they have that contract review where they bring in members of their team, engineer manager, manufacturing manager, quality, that side of it, and they're just reviewing it at that point in time. Whereas the standards are trying to spread that out and make them look at it in a much more proactive way, and they use different methods for doing that, such as the FMEA side of it, down to
look at the risk in processes,
the risk in them, the control plan side of it. Just trying to make the vendors look at things in a bit more granular detail before going into that manufacturing state.
So you mentioned they're reactive and proactive. Reactive being, do you think there's I don't like to use the word misunderstanding, but probably just maybe it's lack of knowledge in terms of the tools that are included in those guidelines. So 9102, for example, we know is all about taking the engineering drawing, capturing it, proving that you've got the dimensions, material certs, process certs and everything as a report. But the more advanced bit, when you look at APQP or AS9145 in the PPAP, allows them to be proactive if they do it correctly. It's still, there's still probably examples out there where they're reactive. I think you just mentioned something there around the FMEA being that, yes, we've done it, but because they've done it there and then for that requirement, they're not necessarily using it in its correct way as a tool for quality, because improving processes. Because
it's not just that one person doing it, it's a team of people doing it. But to get that team of people to look at the FMEA side of it, it's got to be, you know, spread out over a longer period. But looking at the process as a whole, rather than just, you know, at that contract review, a 1 hour meeting, it could be, where within that 1 hour meeting, they're reviewing other parts. So they're maybe only spending 5-10 minutes on that order. And ultimately, what that stops is for them, or helps with, is the quality, which has the effect on on-time delivery. So if you're being reactive to something that's happening down through the process when you're in manufacture, it's going to affect your.
They're all unknowns.
Your delivery, So it has that, you know, that compounding effect.
Steve, thanks for joining me today. I've really enjoyed this conversation. If there was 3 takeaways for people listening, what would they be from the conversation we've just had? Yeah,
so the takeaways for me, utilising software enables you to save time, to mitigate risk, reputational, any reputation damage, and then also streamlining your processes to focus on what's important.
Yeah, I like that. Yeah, focus on what's important. I guess for me, I mean, I do like that personal one when I looked at the process flow and saying start at the back and work backwards to the front. You see things that you wouldn't normally see. But I guess the big one is, if we had our time again, knowing what we've got around us in terms of technology and software, there will be lots and lots of improvements. We can name them from standardisation of processes to retaining documentation. But I think everybody's got it within them to utilise these tools, not necessarily always reactive, but be proactive. Use it to prevent, because that's what we're all about here, preventing things happening. And the use of software, the use of applying those processes and procedures is the biggest takeaway for me from listening to you. But it's been a pleasure. Really enjoyed it. And we hope the audience have too. So
thoroughly enjoyed it.
Cheers, Steve.
Thanks, Greg.